How's it going, guys? My name is Stephen, and this is another code along video tutorial. In this video, I'll be showing you how to use Spark Coalesce and Spark Repartition. So it's a Coalesce transformation method and Repartition transformation method in Spark. So I already created my project. If you don't know how to create a Spark project or using Scala in Intellij IDEA, I made a video on that. You can check that video out. And so I already created the project. So this is my build.spt, and I'm using the Spark core and the Spark core dependency. So I've already created some some packages, for example this one and this one. But for this tutorial, I'm going to create a new one. So I'll just click that and go to new and go to package. So just going to wait a bit for that. Need to type in package. Okay, so I just type the package name. Let's say Coalesce and Coalesce and repart tutorial. So that will create a new package for me, and so this is the package. So inside that package, I want to create a new a Scala object. So I'll just call this one Coalesce. Let's say Coalesce and Repartition. I want to create. Okay, press enter. So what I'm going to do is extend up. So what I need to do next is create a Spark session. Spark equal to Spark Spark session dot builder dot master. I want to give it a because I'm working in local. I'm using my local system, so I'm going to give local with 3 cores or 3 threads, and the app name is going to be Coalesce and Repartition and gets or create. So that is my Spark. I want to set the log 11 to error. Spark.spark dot set log 11 to error. So that will get rid of unnecessary log on the console. It will only log some stuff on the console if there is error. So that is what that one is doing. The next thing I need to do is basically create an RDD. So var RDD1 equal to spark context dot parallelize. So I'm going to just use some number from range of 0 to or let's say 1 to 25. So from range of 1 to 25, and so I'll just leave that one that way. So if I want to print the size of the partition of that data, so I'll just write print how did you want a partition size is equal to how did you want the partitions the size. So that should print the size of the partition. So what I want to do next is actually print the partitions, all the partitions onto the console. So if I use print let's say how did you want the for each partition and iterator. So what I want to do is basically print each partition. Instead of doing that, I'll just use this simple method dot list. So I just use the print here, print line. So this and here's print line iterator dot list. So that will print each partition onto the console. So if I run the application now, so I just so the partition size is 3. You remember we keep this 3 threads, so that is why it partitioned the data into like 3 partitions. So you can see it starts from 1 to 8, and from 9 to 16, and from 17 to 25. So now we have 3 partitions. What I want to show you here is basically another thing I want to show you is I'm going to create or let's say I'm going to give this one a partition number instead of using the default partition. I'm going to give it like a 6 partition. So if I give it 6 partition, it's going to print out the partition size of 6. I'm going to partition this data into 3 partitions. So the next thing I'm going to do next is use repartition. Well, how did you want repart equal to how did you want dot repartition? I want to partition into 4 partitions. So you can see. So now instead of now we have 6 partitions, right? So it's now group this data into 6 partitions, 1, 2, 3, 4, 5, 6. So as you can see, we have this partition from 1 to 4, and this one from 1 to 6, 5 to 8, this one from 9 to 12. So if I use repartition right now, yeah, and I print the size of repartition. So let's say RDD1 repartition size equal to RDD1 repart the partitions the size. So and if I go ahead to print the list of the partitions here, so you will see it will reduce the partition to 4 partitions instead of 6. So that will be RDD reparts. So if I run it now, so instead of having 6 partitions now, we are going to have 4 partitions, and those data will be shuffled, so it's basically what it's doing is basically reducing the number of partitions to 4 instead of 6. So we have 2 partitions deleted, and the data within those 2 partitions will be shuffled across the rest of the 4 partitions. So as you can see here, this data now they are shuffled across the rest of the 4 partitions. So now we have 2 partitions less. So you can see here we have 6 partitions here, right? And now we have 4 partitions here. So that is basically what repartitions do, what it does. And if you have a look at this data, right, you see we have instead of having 1, 2, 3, 4 here, we don't have it here. In the first partition here we have 2, and the next one is 8. So if I go have a look at the original partitions, right, we have 1, we have 2. So what is the repartition is doing is basically shuffling the data around. So it takes these 2, right, it puts it in the first partition, and next go to the next partition, which and take 8 out of that partition, put it here, and go to the third partition, take 9, put it here, and the 4th partition as well, 13, the 5th partition 19, and the 6th partition 24. So it's just like shuffling the data, going through all the partitions and trying to reduce the number of those partitions, just shuffling the performing total shuffling of the data. But in case of Coalesce, it doesn't like perform like total shuffling. So I'll show you how Coalesce does its own here. So if I do RDD1 Coalesce equal to RDD1.coalesce, and the number of partitions, so we want to reduce it to 4 here. So if I print if I copy this one, right, and put it here, so RDD1 Coalesce size RDD1 Coalesce the partitions the size, and RDD1 coalesce dot for each partition, so it will print each of these partitions. So right now what we are doing is using coalesce to reduce the number of partitions from 6 to 4. So you will see that coalesce is not going to perform like total shuffling of the data. So just in a bit you will see how coalesce does it all. So that's the first original partition, which is 6, and the repartition is 4. Now we have coalesce 4. So right now, yeah, you can see what coalesce is doing in this first partition is, so it takes it reduces the partitions to 4 and delete 2 partitions. So so as you can see in this top partition here, right, we have 5, 6, 7, 8. So what coalesce we do is basically delete the second partition and get all the data, move all the data from this one and add it to the top partition. So we have 5, 6, 7, 8, 9, 10, 11, 12. So it's not like performing full shuffling. It's not like going through each of the partitions and just moving the data from one partition to another. You just move like a set of data from a partition to another partition, as you can see. So we have 5, 6, 7, 8, 9, 10, 11, 12. And for the first partition, you just leave it like how it is. So 1, 2, 3, 4. And let's go to the next one. So for the third partition, right, what it does is it takes this partition, the fifth partition, and 17, 18, 19, 20. So it takes all the data from the last partition and just move it to the fifth partition. So what it does is it deletes this last partitions, and I think this second partition, just move the data to the other partition. So you can see it doesn't touch this one, the 1, 2, 3, 4, and this 13, 14, 15, 16. So it's not like going through all the partitions and moving the data. It's just like getting the data from the partition that we want to delete and move it to another partition. So that is why coalesce is a bit more efficient and less costly, but repartition is more costly because it performs like full shuffling of the data among partitions. So basically that is the difference between repartition and coalesce. Also, you can use repartition to increase the number of partitions, but you can use coalesce to increase the number of partitions. What coalesce does is only reduce the number of partitions. So the next thing I want to show you is how to basically save these partitions to a file. So what I'll do is I want to save the coalesce to a file. So I'll do one coalesce dot save as text file, and I'll specify the file directory. I'm going to my home directory, Stephen. It's a workspace. I want to save it under coalesce partition directory. So that should save that one. So if I run this application again, it should save it to my file. So I'm just going to command line cd workspace ls. So these are the data I have in these are the files or the folders I have in my workspace. So I'm going to wait for this one to finish before I can check it again. So that is correct, right? Now it's probably saved it. Let me check again. Yes. Okay, that is it. This is the one. So it saved it to that directory. So I'm just going to check that directory. CD Coalesce Partition. Now you can see we have because it's a full partition, right? We have it starts from 0, 1, 2, 3. So we have 1, 2, 3, 4 partitions. So you can check the data in the first partition using parts 0, 0, wait, parts 0, 0, 0. What am I typing? 0, 0, 0, 0, 0. So 1, 2, 3, 4, and the second partition, which is 0, 0, 0, 0, 1. So we have 5, 6, 7, 8, 9. So you can see the data is moved from let's see, what is it? So we have 5, 6 to 7, 8, 9, 10, 11, 12, right? So that is what the second partition is. And the third partition, let's see. So that is 13, 14, 15, 16. So 13, 14, 15, 16. And so you can check for the fourth partition, which is now we have 17 to 25, which is this one. So that is how you can basically save your partition to a file, and also you can use you can read that partition, right? So if I say val new RDD, or let's say RDD1 partition equal to spark context text file. So the directory is file directory. So I'm going to, and it's in home. Let me just copy this one, paste. So I want to read the second partition, which is part 0, 0, 0, 0, 1. So I can say RDD1 partition dot for each. I want to collect dot for each, and I want to print it. So that should print the second partition for me as RDD. So this is basically reading a text file as RDD, right? But you could read a text file from your HTFS directory. Yeah, I think there is a mistake somewhere. There is error somewhere. So output directory file home workspace Coalesce partition already exists. Okay, since this one is already exists, I just need to get rid of it. There is a file, it's like a big text file I have in my local system. I want to show you how I can read it with as RDD. So you can see, right, we just read only the second partition, which is 5, 6, 7, 8, 9, like this one, right, 5, 6, 7, 8, 9, 10, 11, 12. So as you can see here, the second partition is this one part, no, 1. So that's it. Another thing I want to show you is basically, let me define for RDD2 equal to spark context dot text file. Where is this file then? I think it's in my home directory, home station. I think it's in workspace, and so it's basically a big text file, right? And what I want to do is basically partition it, right, into like 10 partitions. And so what I want to do is save all that partitions into a file, right? So file, right, rdd2 dot save as text file, right? And let's see, where can I save it? Home station, work space, and let me say text or Shakespeare partition, Shakespeare partition. So okay, that one should save it into Shakespeare directory. So I'll just go here. So if I go back and inside workspace, now we don't have Shakespeare partition, right? We just wait for the program to finish running. Partition size and Shakespeare partitions. Yeah, it's finished. Okay, let me check again. Okay, we have a Shakespeare partition here, right? And I just go into that directory, cd paste ls. Now we have a partition from 0 to 9 here, so it's 10 partitions. So if I print the first partition cut part 0, 0, 0, 0 by 0. So you can see this is the first partition, right? This is the whole text in the first partition. So and you can see, let me expand this. You can see this partition start from the project Gutenberg ebook of Shakespeare Sonnet by William Shakespeare, right? And it ends with so I compared it to a summer's day. Okay, let's check the second partition. So you can see it doesn't end with so I compare it with maybe summer's day something, and it doesn't start with what is it? So it doesn't start with it starts with thou art more lovely and more temperate. So it doesn't start with this one, which is the project Gutenberg. So if I check the last partition, which says 9, what 9, okay. So it ends with this website includes information about project Gutenberg, including how to make donations, blah blah blah. And it starts with where is it? So it starts with 1.8.4. Do not own it, blah blah blah. So you can see we have different data in different partitions, right? So that is basically how you basically use Coalesce and Repartitions in Spark. So yeah, I think that's what I want to show you in this video, and so I appreciate you for watching this, and I hope you've learned something. And if you like this video, don't forget to hit the like button and subscribe. Also, yeah, I'll be uploading more videos on like how you can and how to perform some operations using data engineering tool. So yeah, thank you for watching and have a good day. Bye.